See the first thing behind this one. In the gravitation, we are having three laws. I hope you remember them. Kepler's first law, second law, and third law.
Yes, sir.
Kepler's first law is defined as what, beta? Law of orbits. Every planet
Yes, sir.
in the sun in the circular orbit. Important, damn sure question to the gravitation law. First one is known as a what? Law of your orbit. It says that every planet revolves around the sun in a circular orbit. And second one is known as law of areas. Important, none of the numerical society. What is the Kepler's second law? Kepler's second law is known as of your law of your areas. First law, first one is known as of your law of your orbits. Law of your orbits. What is the law of orbits? This is every planet revolves around the sun in elliptical orbit. In elliptical orbit. Okay. Next one. Next one is known as of your law of areas. That means when a planet is revolving around the sun, it covers the equal areas in the equal intervals of time. That is the reason we are having almost all same number of days in every month, leaving the leap year and leaving the sum of the days in a month, isn't it? So every planet revolves around the sun in the circular orbit.
Yes, sir.
The elliptical orbit. And this one is like, say, for example, sun, which is one of your foci. And this is, say, for example, our planet, isn't it? Like, say, it has gone from the point P to your point Q. So whatever area it has been covered in the point P in a time T, the same amount of the time is being covered from this one. So area covered in this one is always remaining constant. Or when the planet is somewhere here right now, at this point and at this point, the area covered when it is near is also equal to the area covered in the point when it has been far away. Clear?
Yes, sir.
So that is known as what? Law of your areas. Law of area says that area covered, that is nothing but delta A divided by your delta T. Area covered in a given interval of a time is always equals to your constant. That constant value is equals to L by your 2m. L is the angular momentum, m is the mass. Got it?
Yes, sir.
So next one. Next one is known as of your law of periods. Law of periods. All these laws are given by the Kepler. That is the reason they're also called as of your Kepler's first law, second law, and third law. Okay. Kepler's third law says that Kepler's third law is other name for the Kepler's third law is law of periods. It says that square of the time period is directly proportional to your cube of the radius. That is nothing but of your AQ, semi-major axis. Okay.
Yes, sir.
We will get a lot of number of problems based on this one. But Kepler's second law is rate of change of area is always remaining constant, and that value is equal to how much for your L by your 2 times of your m. Whereas Kepler's third law is known as what? Law of periods, which says that square of the time period is directly proportional to your AQ. Okay. Sure. Next one is known as Newton's laws of gravitation. Newton's law of gravitation. Gurdunda, same like electrostatics. Same like electrostatics.
Yes, sir. 1/4 perhaps.
So here it could వచ్చేసి ఏమైపోతుంది. So like now this one is a particle of mass m1 and this one is a particle of mass of your m2. And both of them are being separated by certain distance, like say for example of your r. Force is directly proportional to product of masses and inversely proportional to the square of the distance between them. So F will be equal to your G into your M1, M2 divided by your R square. G is your what beta? Universal gravitational constant. G is known as what beta? Universal gravitational constant. Clear?
Yes, sir.
Sure. And next one, and very important relation. Relation between small g and capital G. Relation between small g and capital G is given by relation between small g and capital G. What is small g and capital G? Small g is acceleration due to gravity and capital G is your universal gravitational constant, this value. So the relation between them is given by the formula. Small g is equals to your capital G, capital M divided by your R square. M is your mass of your planet and R is the radius of your planet. If it is on Earth, you take mass of Earth, radius of Earth. If it is on your any other planet, you take the mass of that planet divided by R square. Your mass can also be written in terms of density. Mass is equals to volume into density. Volume will be equal to 4 by 3 pi into your R cube into rho, because we assume all the planetary orbit in the terms of your circular orbit, unless and until is specifically mentioned. Okay.
Yes, sir.
So what will be the mass of the Earth, beta? Mass of the Earth ఒకవేళ calculate చేయాలనుకోండి. So mass of your Earth will be equal to E G ఇక్కడ వెళ్ళిపోతుంది కాబట్టి G into your R square divided by your gravitational constant. That will be the mass of your Earth. Because G is a constant, radius of Earth is a constant, and G value is also a constant. Okay.
Yes, sir.
Sure. And one more and very important relation. When the body is taken to certain height, like say this is your Earth, and this is the radius of the Earth, and here there is a body. When the body is on the surface of the Earth, the relation between your capital G and small g, this is the mass of the Earth is capital M, isn't it? And this is your reference. From this reference, when the body is taken to a certain height, right now to somewhere here, I've gone from the surface of the Earth to height of H. That means what is the total distance have been traveled from the center of the Earth? R plus H. So in that case, G at a certain height is given by the formula G divided by 1 plus H by your R. This is applicable for any height. So G at your height is equal to how much for me? G divided by 1 plus H by your R whole square. When H is very, very small, when H is much, much lesser than R. The radius of the Earth is how much, better? Idea on that? Radius of the Earth is 6,400 kilometers.
Yes, sir.
Taking the height like 30 kilometers, 40 kilometers, 100 kilometers, that is very less compared to 6,400 kilometers.
Yes, sir.
So in that case, we'll be writing G at a certain height will be equal to G into 1 minus 2H divided by R. Then the binomial expansion expand చేసుకుంటున్నాము. So G at certain height will be equal to G into 1 minus of 2H divided by your R. And this formula is applicable for your any height. And this formula is applicable only for at a certain height part of relation. Okay.
Yes, sir.
In the same way, when the body is taken to certain depth, ఇప్పుడు సర్ఫేస్ నుంచి ఇక్కడ పైకి తీసుకెళ్ళాము, అదే ఆ బాడీ ఏమో కొంచెం కిందకి తీసుకెళ్ళాము అనుకుందాం, ఇక్కడికో తీసుకెళ్ళాము. యువర్ డెప్త్ ఆఫ్ యువర్ డి అంటే సెంటర్ నుంచి ఎంత డిస్టెన్స్ అయిపోతుంది? R minus D కదా?
Yes, sir.
Isn't it? So I can write here G at a certain depth is calculated by the formula G into your 1 minus of your D divided by R. D is nothing but what your depth. So if you need to calculate acceleration due to gravity at a certain depth, you can use the formula G into 1 minus of your D by R. Okay? The same way.
Yes, sir.
Effect of rotation. Effect of rotation of Earth. Okay. So when Earth is also rotating, there is a change in acceleration due to gravity at your equator and at the poles. And that is given by the formula G dash will be equal to G minus of R into your omega square into your cos square phi. Phi is nothing but what? Latitude. Phi is nothing but what, better? Latitude of your Earth at which it is making certain angle. So G at a certain angle can be given by the formula G minus R omega square into cos square theta ni kuda raskochu lekapothe lambda. Lambda is nothing but angle made by the what do you call that one, with respect to the equatorial line.
Yes, sir.
Like what is the Earth అనుకుందాం. This center with respect to the rotation ikkada Earth ikkada ఉంది. So we are making an angle of your latitude ikkada nunchi ikkada varaku, like say for example of your, this is right now poles, and this angle if I'm taking it as of here, like say for example phi. So this will be your equator, this will be your poles. So tell me at equator, What is the value of phi beta? 0 kada.
Yes, sir.
Lambda or phi is equal to how much for me? 0. So if I'm taking this one to be a 0, tell me in the place of this one. Cos 0 if I'm taking substituting here, what I'm getting? G at your equator will be equal to your G minus cos 0 is how much?
1.
1. That means this will become for me how much? R into your omega square. So this is the value of the G at your equator. Okay. At poles, beta. At poles. So when you're going from here to here, the lambda will become how much for me? 90 degrees. Substitute in above cos 90, 0. That means G at your poles will be equal to G. Tell me where the G is more beta.
Sorry, sir.
Where the value of G is more? G is more at equator or G is more at the poles? This one is G minus R omega square and this one is G. In both of this one, which is more?
Sir, at equator it is less.
Yeah, so G at your poles, I can say is greater than G at your equator. Okay. Sure. In this one, you see, if G at equator is equals to 0, then this will be 0 is equals to G minus R omega square. I can calculate the angular velocity of the Earth in that case. So this will be G is equals to R into omega square. So omega is equals to under root of your G divided by your R. So this is the angular velocity with which the Earth is being rotated. Okay.
Yes, sir.
The next and very important formula which you should remember for doing the problems is gravitational potential. Gravitational potential. Same like electrostatics. Potential is a scalar quantity. So you need to take the sign convention whenever you're doing the problem, represented by your V. Okay. So potential will be equal to your gravitational potential will be equal to your, I'm representing by small g. This is capital G, capital M divided by R. Small r is nothing but equal to your capital R plus of your h bit. Small r is equals to how much? From center of the earth to a certain height h. If it is on the earth, h value will become 0. Then at the time it will become for me minus of capital G, capital M divided by R. Clear?
Yes, sir.
In this one, we also define one more term, gravitational field. Gravitational field. Like electrostatic field. Okay. Gravitational field I am representing by E bar and it is a vector quantity. Negative potential gradient is known as of your gravitational field. So it is minus of your dou V divided by your dou of your R. Negative potential gradient is called as what beta? Gravitational field. Very important formula. We got so many times the problems on this one beta. Like if I'm talking about the gravitational field along your x-axis, this will be equal to your partial differentiation of the potential with respect to your dou x. If I'm talking about the gravitational field along your y-axis, that will be equal to minus of your dou v divided by your dou y. In the same way, if I'm talking about gravitational field along your z-axis, that will be equal to your minus of your dou v divided by your dou z. Got it? That means total vector will be represented by the formula E bar is equals to your Ex into your I cap plus Ey into your j cap plus of your Ez into your k cap. So what is the gravitational field? Negative potential gradient. Negative potential gradient is known as gravitational field. And gravitational potential is equals to your negative of your capital G capital M divided by R. Small r is the distance of that body from the surface from the center of the earth. So value of small r is equals to your R plus of your H. Clear, beta?
Yes, sir.
Sure. Next one again, very important formula. Gravitational potential energy. Gravitational potential energy. Gravitational potential energy represented by letter U. This is also scalar quantity. So UG will be equal to your minus of your capital G, capital M, small m divided by R. Capital M is the mass of the planet or mass of the Earth. Small m is the mass of the body. R is the distance between them. So gravitational potential energy will be equal to your minus of capital G, capital M, small m divided by your R. This one we need to remember one important formula. It is self energy of your Earth. Self energy of your Earth, that will be equal to your minus of your 3 by 5 into capital G, capital M square divided by your R. U is equals to your minus of your 3 by 5 capital G M square divided by your capital R. Very, very, very important formula. That
Yes, sir.
the next one is very important shortcut from your numericals better. How do you calculate change in potential energy? Change in potential energy. It is represented by formula delta U is equals to your mg into your h divided by 1 plus h divided by r. Okay. If h is much lesser than r, then potential energy can be written as of your mg into your h. General potential energy mgh rasam kada. But in terms of your acceleration due to gravity or in terms of your earth, it is mg into your h divided by 1 plus of your h by r. Okay. If it is very small, then we'll write the relation as delta U is equals to mg into h. And the self energy of your earth will be equal to how much beta? Minus of your 3 by 5 g into your m square divided by your r. Very important formula. And gravitational potential energy is minus of your g into your m divided by your capital G, capital M, small m divided by r. Capital M is nothing but what beta? Mass of your earth or planet. Small m is nothing but of your mass of your body.
Yes, sir.
Yeah.
Yes, sir.
Sure. See one question based on this one. Like we said, 4 point masses. 4 point masses, each of mass m. Each of mass m are placed at the corners of a square. The corners of a square of side A. Okay. Question is, find the gravitational force. Find the gravitational force. Gravitational force experienced by each particle. Gravitational force experienced by each particle. We can use the principle of superposition better. When more than 2-3 forces have been present, we can add the forces vectorially. F is equals to your F1 plus F2 plus F3 plus so on. Okay, na? This one is known as what? Principle of superposition. Principle of your superposition. Vectors lo gurtunda. If two vectors are inclined at an angle like this, if this is one force F1 and this is your another force F2 and రెండిటి మధ్యలో angle theta ఉందనుకో, the resultant of this one is right now Fr, which is making an angle of your alpha. So resultant force will be equal to your under root of your, I can write this one as of your F1 square plus of your F2 square plus 2 times of your F1 F2 into your cos of your theta. Isn't it? F resultant is equals to like parallelogram law vector addition. Fr is equals to your under root of your F1 square plus F2 square plus 2F1 F2 into cos theta. An angle made by this one will be equal to your tan alpha. So tan alpha is equals to your F2 into your sin theta divided by your F1 plus of your F2 into your cos theta. And alpha is equals to your f2 into your sine theta divided by your f1 plus f2 into your cos theta. These are the basic formulas. Now read this question better. What is the question is telling? Four point masses, each of mass m, are being placed at the corners of a square of side A. Find the gravitational force experienced by each particle. Now let me draw the square. Like say this is your square. Okay. Now four particles are kept at the four corners. This is one particle m. This one is your another particle m. And this one is your another particle m. And this one is your another particle m. And all of them are placed at the corners of side A. This one is side A, this one is side A, this one is side A, and this one is side A. Find the gravitational force experienced by each particle. Like say if I take any one particle as a reference, okay, let me take this particle as of your reference bit. The thin pine of force, this will exert the force beta F. This particle will exert the force on this particle in the downward direction. This one is also F because masses are same, distance are same. This particle will also exert the force on this one better like this. So this one is also your F. Okay.
Yes, sir.
These two forces are perpendicular to each other, but like
Yes,
say,
sir.
these two forces are perpendicular. So if it is perpendicular, use this formula. Theta is 90 degrees. F1 is F, F2 is also F. So this will become for me how much? Root 2F.
Yes, sir.
Because this one is your F square plus 2F square into cos 90. Cos 90 means this total will go here. It is root of your F square plus root of your F square. So this you take it as F square, this you take it as F square. It will become how much for me? Root 2 times of your F. This one is exerting the force on this one. So F net will be equal to how much? Can you tell me? F net will be equal to your root 2 into your F plus of your F. This you take it as F dash, otherwise you'll get a clarity. This is your F dash. Now tell me what is F first. F is equals to your capital G, M into M, M square divided by your A square. F dash will be equal to how much beta? That is capital G into your M square divided by, distance between this one is diagonal, so it will be your root 2 into your A ka whole square. That means this will become for me G into your M square divided by 2 into your A square. Okay, na?
Yes, sir.
So now F net will become how much for me? F net will become for me equal to root 2 into F value already I got, you write that one, G into your M square divided by your A square plus this one is your G into your M square divided by 2 into your A square. So in this one, what is common right now for me? F net is equals to your F net is equals to your capital G into your M square divided by your A square into your root 2 plus of your 1. So F net is equals to G into your M square divided by your A square into root 2 plus of your 1. Then,
Yes, sir.
no doubt in this one?
No, sir.
Root 2 plus of your 1 by 2. 2 on the other, Chipawa. Gm by A square divided by 2i. There,
Yes,
Gm
sir.
A square common, Gm A square common. So it is root 2 plus 1 by 2.
Yes, sir.
And I can even write like this. F net will be equal to G into your M square divided by 2 into your A square into 2 root 2 plus 1. Ask question.
Yes, sir.
Direct questions basically. Okay, na?
Yes, sir.
Next one is an important area that is about your satellites. And escape velocity or escape speed, I can say. And orbital velocity.
On, sir.
Satellites, escape speed, and orbital velocity. First one. If I'm talking about orbital velocity ante enna? Like this is your Earth, and this is your radius r, and here is some planet, some satellite, sorry. And this satellite is revolving with a certain velocity v naught, like this. Okay, and this is at a certain height from the ground. So orbital velocity, small r will be equal to your capital R plus of your h. What is small r? The distance from the center of the Earth to this one is nothing but small r. So orbital velocity will be equal to how much? V naught is equals to under root of your capital G into capital M divided by your small r, isn't it? So I can write small g is equal to how much better? Small g is equals to capital G capital M divided by r square. So capital G capital M can be written as g into your r square. So orbital velocity will be equal to under root of your g into small r square divided by r. R and r will get cancelled. So orbital velocity is also equal to under root of g into your r. Ante kada? What is small r? Small r is equals to r plus h. Then
Yes, sir.
and time period of revolution is given by the formula T is equals to your 2 pi divided by omega. So it is equals to your 2 pi divided by omega. How do you write? V is equals to r into omega. Is the orbital velocity. And
Yes, sir.
omega will be equal to your V naught divided by r. So it is your V naught divided by your r. So that will be equal to 2 pi into your r divided by V naught is how much? Under root of your. This will be equal to your G into your M divided by your r. That means this can be written as of your 2 pi common. This is under root of your r cube divided by capital G capital M. Can I write like this? So time period of the planet which has been revolving around the circular orbit is given by the formula 2 pi into your r cube divided by G into your M. From this only we got the Kepler's third law. Squaring on the
Yes, sir.
both sides, what will be relation I'll be getting beta? T square will be equal to your T square will be equal to 4 into your pi square. This will become for me r cube divided by G into your M. This total term is right now constant. So that is the reason we say that square of the time period is directly proportional to your r cube. Kepler's third law. If I'm writing in terms of error, this will become how much for me? 2 times of delta t by your t will be equal to your 3 times of delta r divided by r. So delta
Yes,
t
sir.
by t will be equal to how much? Delta t divided by t will be equal to 3 by 2 times of your delta r divided by r. Very important formula. Got it?
Yes, sir.
Orbital velocity value in any planet which is revolving around the surface of the Earth is around g into your g value, we know 9.8. Radius of the Earth is 6,400 kilometers. If satellite is very, very lesser than of your Earth, when I'm using this relation, if small h is much, much lesser than of your Earth, then this will be the orbital velocity. And value of this orbital velocity is equal to how much for me? Gurtunda? 8 kilometer per second. That means a satellite which is been revolving around the planet will be moving with what speed beta? 8 kilometer per second. And time period formula will be equal to T is equals to 2 pi under root of your. This will become for me capital R divided by G. Endukante is smaller la R plus H whole cube kada. If H is very, very small, I can represent that one as what beta? R cube.
Yes, sir.
So if I'm simplifying that all relation right now, we can write in terms of your capital G, capital M, I can write as G into R square. Is simplified, we'll get it in time period T is the 2 pi under root of R by G. The value of this one comes out to be 84.6 minutes. Done?
Yes, sir.
So orbital velocity formula in the V naught is equals to under root of your G into small r, where small r is R plus H. If it is very nearer to the surface of the Earth, the value is under root of your G into R. The value of H is equals to very, very less. Orbital velocity value is 8 kilometer per second. Done?
Yes,
This
sir.
one. What is the kinetic energy of this satellite which has been revolving? Kinetic energy will be equal to your capital G, capital M, small m divided by 2r. Like half into m into v square. You simplify it, we'll be getting this one as kinetic energy. So once I know the kinetic energy, then total energy will be equal to sum of potential energy and kinetic energy, isn't it? So it is your potential energy plus kinetic energy. Potential energy is minus of capital G, capital M, small m divided by your R. Plus this one is capital G, capital M, small m divided by 2 times of your R. So I'll be getting the total energy will be equal to how much beta? Minus of your capital G, capital M, small m divided by R. Then
Yes, sir.
total energy will be then
Yes,
1
sir.
minus up to R gadra. Total energy.
Yes, sir.
So total energy is equals to minus of your capital G, capital M, small m divided by 2. Around add chedu minus of 1 plus 1 by 2 kada. Minus 1 by 2. Antena?
Yes, sir. Yes, sir.
Potential energy formula enta undena. Potential energy was represented by U. U is equals to minus of your capital G, capital M, small m divided by R. Inta mundu rashan. If I'm taking the relation between them, kinetic energy will be equal to your minus of total energy. That is equals to minus of your U by 2. Kinetic energy is negative of your energy రాసుకోవచ్చు చూసుకో సార్ kinetic energy is equals to potential energy. ఎంతుందన్న
Yes, sir.
kinetic energy is nothing but what? Negative of your potential energy. Racha,
Answer that.
this is your total energy. Kinetic energy is equals to minus of your total energy.
Yes, sir.
Kinetic energy is also equal to, see here, capital G, capital M, this value, minus of your capital G, this capital G, capital M by R can be written as of your minus of your what? U by 2. Then,
Yes, sir.
very important relation. Chanasal అడిగాడు కూడా దీనికి బేసికల్. ఇంకో satellites ఉంటాయి, that is called geostationary satellites. గుర్తుందా? whose time period is equal to surface 24 hours. Geostationary satellites. Geostationary satellites. The satellites whose time period is how much better? 24 hours. And they will be moving with an orbital velocity of your 3 kilometer per second. And they are at a height of your 3,600 kilometer. Okay.
Yes, sir.
And the last one is escape velocity. Represented by V. The velocity with which a body should be moved so that it will escape the surface of the earth. That is given by the formula VE is equals to under root of your capital G, 2 times of your capital G, 2 times of your capital G, capital M divided by R. That is equals to capital G, capital M is how much better? G into R square gada. So it is under root of 2 into capital G into your R square divided by R. ER వెళ్ళిపోతుంది. So escape velocity will be equal to under root of your 2G into your R. Escape velocity is under root of your 2G into your R. And the value of this one is how much better? 11.2 kilometer per second. Okay.
Yes, sir.
Very important formula. Escape velocity in terms of small g and escape velocity in terms of capital G, capital M. If you good to how I got that value, small g is equals to capital G, capital M divided by R square. So capital G, capital M will be equal to G into R square. That value I substituted here, right? So that is the reason I got the value of escape velocity is under root of your 2 times of G into R. Now see for black holes, this is NCRT point winner. Escape velocity will be greater than or equal to the speed of light. Okay, condition for the black holes. Escape velocity must be greater than or equal to the speed of light. That means under root of your 2 times of your capital G, capital M divided by your R will be greater than or equal to your C. That means I can write from this one, capital R is lesser than or equal to 2 times of your capital G, capital M divided by C square. Radius of the black hole, this will be the formula. Done, madam?
Yes, sir.
So these are some of the basic problems which you need to remember for doing the numericals related to for this. Okay, na?
Yes, sir.
Time period relation is also very important. You need to remember this relation better. Purely formula based problems వస్తాను అన్న దీంట్లో కొంచెం ఎనర్జీ కన్జర్వేషన్స్ వస్తాయి అవి నేను అప్లికేషన్ చేపించేస్తాను సో విల్ గెట్ ఎన్ ఐడియా హౌ టు రైట్ ఫర్ ద గివెన్ కండిషన్స్ ఆల్సో సో వాట్ ఈస్ అన్ ఎలక్ట్రిక్ ఫీల్డ్ gravitational field is nothing but what negative of the potential gradient is known as of your gravitational field. G at equator is G minus of r omega square. G at poles is your G and G at equator is this value. Angular velocity value omega is equal to how much for me? Under root of your G by your r. The general formula for acceleration due to gravity is G dash is equals to your G minus of r omega square into cos square phi. And G at a certain height for any value is given by this formula beta. If height is very, very less, then G at your height will be equal to your G into 1 minus of 2h divided by r. Relation between small g and capital G, or mass of your earth will be equal to this much. Gravitational law, F is equals to your capital G, m1, m2 divided by your r square. Law of your period, square of the time period is directly proportional to your r cube. Our delta A by delta T is equals to constant, that is L by 2m. L is known as what beta? Angular momentum.
Yes,
L
sir.
is nothing but your angular momentum. In rotation, angular momentum is how much? I omega. And in the mechanics, L is equals to mv into your r, or L is equals to your r bar cross p bar. Okay, na?
Yes, sir.
What is a p? P is momentum. P is equals to mass into velocity.
Yes, sir.
These are the standard formulas which you need to remember to do the numericals on your gravitation. Damn sure ga question compulsory ಬರ್ತದೆ.
Yes, sir.
దీనిలో గ్రావిటేషన్ క్వశ్చన్ ఏమైనా ఉందో చూడొచ్చు సార్. This is friction question. This is our mounted particle diagram. Yeah, this was the gravitation question yesterday what we did.
అవును సార్ ఇది నేను ఉన్నా ఈ
Orbit
క్లాస్
very
లో.
close to the surface of planet with the speed v naught. At some point, it is given an impulse along its direction of motion, causing its velocity to increase neta times. As the satellite goes in an elliptical orbit, the maximum possible value of neta for a satellite to move in the elliptical orbit is how much? When it is at a certain height, G is equals to capital G capital M divided by r plus h whole square. Orbital velocity formula under root of G into r plus h. Is it r is under root of gm by your r. Escape velocity is this much. So escape velocity and orbital velocity మధ్యలో relation ఎంత అంటే v is equals to root 2 times of v naught. So when n is lesser than or equal to root 2, then it is maximum particle will be having the maximum possible velocity for the satellite to move in the elliptical orbit. Okay.
Yes, sir.
TYQs బుక్ పంపించాను కదా మీకు దాంట్లో నుంచి తీసి ఒకసారి ఈ రోజు గ్రావిటేషన్ ప్రాబ్లమ్స్ చేసేసి
ఓకే సార్ చేస్తాను.
ప్రాబ్లమ్స్ అనేది నేను కూడా రేపు ఒకసారి గ్రావిటేషన్ ప్రాబ్లమ్స్ చెప్పిస్తాను. మనం గ్రావిటేషన్ పేపర్ పంపించాను చేసావా?
మీరు చాలా పేపర్స్ పంపించారు సార్.
ఒకటే పంపించాను నీకు. జే మీన్స్ ఒకటి పంపించాను మన
చూసుకున్నాను సార్, సాల్వ్ చేయలే కూర్చొని. ఐఐటి మెయిన్స్ మాక్ టెస్ట్ నా
క్వశ్చన్ పేపర్ దియో సార్, నేను గ్రావిటేషన్ క్వశ్చన్ కూడా చేసుకున్నాను సార్.
ఏ పేపర్ సార్? ఐఐటి మెయిన్స్ మాక్ టెస్ట్ నా
17 నారాయణ పేపర్.
ఓకే ఓకే అదా. చేసినాను సార్ ఒక
చూడ సార్ గ్రావిటేషన్ క్వశ్చన్ ఎక్కడ ఉందంటే read the question and see where is the question.
Yes, sir. Okay, నిమిషం.
First one is nothing but what better? Two bodies of mass 10 kg and 5 kg moving in a circular orbit of radius Kepler is smaller such that the periods are same. The ratio of their centripetal acceleration is your how much? Chapter.
సార్ ఇది గ్రావిటేషన్ క్వశ్చన్ నా?
గ్రావిటేషన్ కాదు, సెంట్రిపిటల్ ఫోర్స్. డైరెక్ట్ క్వశ్చనే కదా, అందుకోసం అడిగారు. ఓకే, లేకపోతే గ్రావిటేషన్ క్వశ్చన్ తీయవు సార్. లేకపోతే
సార్ ఇది చెప్తాను, ఒక్క నిమిషం. ఆ రిలేషన్షిప్ గుర్తొస్తలేదు. సార్ R/R ఉంటుంది కదా, ఆప్షన్ 2.
ఓకే, గ్రావిటేషన్ క్వశ్చన్ అయితే ఇవ్వలేదు. ఆప్షన్ ఎంత వచ్చిందన్న ఆన్సర్?
ఏ క్వశ్చన్ సార్? ఫస్ట్ క్వశ్చనా? సెకండ్ ఆప్షన్.
సెకండ్ ఆప్షన్ వచ్చిందా? ఏమొచ్చింది?
R/R.
క్యాపిటల్ ఆర్ బై స్మాల్ ఆర్ రావాలా?
క్యాపిటల్ ఆర్ బై స్మాల్ ఆరా?
సెంట్రిపిటల్ యాక్సిలరేషన్ ఫార్ములా ఏంది?
V²/R.
AC is equals to V square divided by R. V is equals to I can write as R square omega square divided by R kada. ER వెళ్ళిపోతుంది. So centripetal acceleration will be equal to your omega square into R. In terms of time period రాసినప్పుడు this is capital R divided by your small r is equals to your omega of your capital R square into capital R divided by omega of your small r square into small r. What is omega value beta? Omega is equals to 2 pi by capital T kada. That means this is the capital time period of the small r divided by capital R into your capital R divided by small r. And then
yes sir.
In the problem is telling that time period of your capital R is equals to time period of a small r. This cancel అయిపోతుంది. This will become for me capital R by your small r.
Yes sir.
Okay na?
Yes sir. కానీ సార్ ఇది ఒమేగాలో ఎందుకు అట్లా కన్వర్ట్ చేసుకున్నాం?
సర్క్యులర్ ఆర్బిట్ లో మూవ్ అయ్యేటప్పుడు ఏమైపోతుంది? whenever a particle is moving in a circular orbit, it will be having angular velocity కదా, omega. So we know the relation V is equals to R into omega. Straight line లో పోతే V, circular path లో పోతే omega.
కానీ సార్ V²/R రేషియో కూడా తీసుకోవచ్చు కదా?
V²/R ఎందుకు తీసుకోలేం కదా? V²/R అనేది right now this is for your centripetal acceleration when velocity is constant.
Okay.
Angular velocity move అయ్యేటప్పుడు we need to write in terms of your omega.
Okay sir, అర్థమైంది. Yes sir.
I've sent you one more question today. Sorry, gravitation, there is one question, please try to open it. Question number 14 చూడు సార్.
సార్ ఈ 17th పేపర్ లో లేదు కదా ఒక క్వశ్చన్ కూడా గ్రావిటేషన్?
ఇప్పుడు పంపించాను చూడు ఇప్పుడు.
yes sir, దీంట్లో ఫస్ట్ క్వశ్చన్.
క్వశ్చన్ నెంబర్ 14.
Okay. Yes sir.
చూడు సార్ క్వశ్చన్ చదువు. 14th one.
Acceleration
to gravity on the Earth's surface at the pole is g, and angular velocity of the Earth about the axis passing through the pole is omega. An object is weighted at the equator and at a height of h above the poles by using a spring balance. If the weights were found to be the same, and if h is much lesser than r, then what is the relation between them?
G equal to G into 1 minus 2h/r.
So G it is certain height when it has been rotating. Just now I told you the formula for that one.
Yes sir.
Isn't it? What is the formula?
G multiplied by 1 minus 2h/r.
Yeah. So what is the formula? G at your equator will be equal to G minus of R into your omega square. And G at a certain height, you know the formula. It is G into your 1 minus 2H by your R. When you will use this formula? When H is much lesser than of your R.
Yes, sir.
అవునా కదా?
Yes, sir.
G at equator ఏమన్నాడు? G at your certain height will be equal to your how much work?
Sorry, sir.
G at a certain height divided by your H. ఎంత అవుతుంది? Height
Sir,
కదా
మీరు ఏం అడుగుతున్నారు అర్థం కాలేదు.
Question చదువు ఒకసారి. What is the data given AC? You know, this is the value of the G at equator and this is the value at a certain height. What is the given condition in the problem?
H is lesser than R.
H is much lesser than R కాబట్టి ఈ formula యూస్ చేశాను నేను.
Yes, sir.
How do you solve this problem now?
సో H కి నెగ్లిజిబుల్ అనుకోవచ్చు కదా?
నెక్స్ట్ నెగ్లిజిబుల్ అనుకో. Acceleration due to gravity on Earth's surface at the pole is given as of G, and angular velocity of the Earth about the axis passing through the pole is omega. An object is being weighted at the equator and at a height of H above the poles by using the spring balance. If the weights were found to be the same, and a weight was being found, and a weight at your equator is equals to weight at your certain height. Weight means
Yes,
what?
sir.
M into G at your equator will be equal to your M into G at a certain height. And this will be equal to your how much? G minus R omega square is equals to, this one is G into your 1 minus 2H divided by your R. Okay, na?
Yes, sir.
ఎంత అవుతుంది చెప్పేది ఒకసారి. This simplify check. G minus R into your omega square is equals to your G minus 2H into your G. So this one is 2H into your G divided by your R. So what I can write from this? R into your omega square is equals to G into your 2H divided by R.
Yes, sir.
So H value will be equal to your how much? H value will be equal to how much? So this one is R into your, this one is your R equal to R square omega square is equals to your 2G into your H. Is asking the value of H. So H value will be equal to your R square omega square divided by 2G. Ante kada?
Yes, sir.
So this will be the answer for this. Today the simple one day if you know the formula.
Yes, sir.
The given condition for me in the problem.
Yes, sir.
Got it?
Yes, sir.
Okay, chalo. This చేసేసుకో ఈ రోజు గ్రావిటేషన్ మరోసారి రివైజ్ చేసేసుకొని అండ్ ట్రై టు డూ సమ్ 2021 లో కొన్ని క్వశ్చన్స్ కంప్లీట్ చేస్తే ఒకసారి.
Okay.